Okay, so welcome to chapter 4. We just went over chapter 3 and looked at survey. Survey is like the first step before you excavate. You have to find out where the sites are, find out what the terrain looks like, and start forming questions about why you think something of value is in the area that you're looking. So this one in chapter 4, now we're going to look at excavation, which, you know, I love doing survey. I love doing excavation. Both are really interesting to me and kind of fun, actually. I haven't done it in a long time because this was earlier in my career. I did more field work than I've done later in my career, of course. It just sort of happens. But anyway, so let's have a look and find the controls down here. There they are. All right, so in this chapter, we're going to look at what determines preservation. You know, when you're doing excavation, what are you trying to preserve for the future? And then we'll look at the principles of archaeological excavation. How do we do it? We're going to look at doing excavation in a precision way, how we sift through the evidence. We'll see that, screening and so forth. Then we have to catalog what we find, or it doesn't make any sense to do it if we don't make records of it. And then we will talk about you only dig what you absolutely have to dig because it's destructive. And once we excavate, we can never make it come back again. So we want to be really careful about what we're doing. All right, so let's start with a really important concept, two really important concepts. One is provenience and the other is context. And they're very linked. So provenience, an artifact's provenience is its location relative to a system of spatial data collection. So where is it in space? And then ultimately, where is that space in time? So that's the most important thing about the artifact. But really, I'd say the most important thing, provenience is essential to recording an artifact's context. So context really is everything. Provenience is super important because you need to know where it is in time and space. But context helps you understand what the relationship of that artifact is to everything around it. Because a single artifact can't give us the story. The story has to come with where it is in time and space, what it's related to in that archaeological context. What is it next to? What does that tell you about what people were doing? So the relationship of an artifact, an ecofact, or a feature to other artifact features, ecofacts, and also to the geological strata in the site are two really important concepts. And I probably would say context is everything. Context is really what we need to know. We can have all the artifacts in the world collected and put on shelves, but if we don't have the context, it really is meaningless. Pretty things, I guess. Huh? All right, so let's get the next slide. All right, so we're going to talk, to start out, we're going to talk about a very important ancient archaeological site called the Folsom site. And we'll talk about the Americas. You'll see me mostly talking about the Americas because the Americas are my specialty. American Indians are my specialty. But also your authors do talk a lot about sites in the Americas, especially in North America, in our area. So the thing that we begin to, when we're looking at North America, well, and other places around the world, but the one thing that really is important when looking at the North American continent is understanding the geological time periods and how they affected how people could actually occupy this area. So we start with the Pleistocene, and that's a period from 1.8 million to 10,000 years ago. And we had lots of periods during the Pleistocene of glaciation and then extensive glaciation, and then it sort of backing off. Yeah, Tanya, you had a question.
Yeah, I'm not sure, are the slides supposed to be showing right now? Because I can't
Yes, they are. Are you not seeing them?
No.
Okay, hold on a second, because that's really important. Why aren't you showing slides? All right, let's try it this way. Do you see it now?
Yes, that's good.
Yay. All right, let's
Thank you.
go. Okay, so you haven't seen any of the previous slides. I don't know if they've been recorded or not. So I'm just going to, everybody be patient for the sake of the recording. I'm just going to show you the beginning slide and talk about, and you'll hear me talk about what that's all about. And then this is just a list, the outline of what's in the unit. And then here's the slide that we just spoke about on provenience and context. Okay, so that should help you a little bit more. And I'll linger on this one just for a second in case it didn't show up to everybody. It may be that I just wasn't broadcasting to you, but it's recording. So
Okay.
thank you for letting me know. I appreciate
All right.
that. All righty, so Pleistocene. Are we on the same slide now?
Yes, we are. Thank you.
Cool. Okay. All right. So that geological period is really important for human occupation of the Americas because we couldn't cross the land bridge, or there was a lot of glaciation that was holding areas, locked in areas when you're talking about coming from say Russia and crossing over into Alaska. But we have a lot to say about that, and that's not perhaps the only way that humans occupied the Americas. But this has been a question for a really long time, and it's still loaded with all kinds of debate. So the artifacts that were with the bones of animals that were living during the Pleistocene helped prove initially that people had been in North America for at least 10,000 years. So when the glaciation melted at the end of the Pleistocene, those animals from the Pleistocene are seen in the Americas in connection with artifacts. So we could say, we can argue all day about when did it happen exactly, but we know, bottom line, at least 10,000 years ago. All right, so the Folsom site was important because when people were first trying to figure out what was going on in the Americas, we needed evidence. We had all kinds of ideas, but we needed evidence. And there was a cowboy by the name of George McJunkin, and he is well known for at the Folsom site for actually seeing some bones that were protruding from the walls of an arroyo. So an arroyo is this big ditch that you see here that forms in the Southwest. And down below, you see the Folsom site in 1998, and a unit that's being excavated, and you see a bison there. So he saw a bison that was huge and realized that it was associated with human artifacts. So George McJunkin found this fluted point, a fluted point, it wasn't this particular one, and tried to draw the attention of scientists to this area. And just, by way of history and Black history, George McJunkin was a Black man who really was interested in the area he was living in, and really pursued a lot of scientific exploration on his own. So anyway, he finally attracted people to come to the site. Well, actually, it happened after his death, unfortunately, but because of his persistence, people finally came to the site. And what they found was a fluted Folsom spear point. So fluted is this channel that goes up the spear point. Whoops, I didn't mean to touch that. All right, it goes right up here. And it was lying between the ribs of an extinct species of bison. All right, so then we could see that this is a Pleistocene animal. That means people were here at least 10,000 years ago. There's evidence. Now, what's important in this evidence is that it was in situ. So that's a term that we use in archaeology, in situ. That means it was in position. It was exactly where it was when the animal went down and nothing had changed in its position. So that helps us validate the age of it. Because the spear and the ribs are in situ, their position, their context, then, and their recorded provenience. So here you'd say the spear point is in context with the ribs, and its provenience, that that place that we have recorded helps us verify this. So confirming that presence, that people had been here since the end of the Pleistocene anyway. And there are still arguments about if it was sooner than that. And we do have evidence that's sooner, and we will talk about that in this course. Okay, so here are some things to think about excavation. Oh, and Tanya, your hand is still up. So you didn't have another question, did you? Okay, good. I just want to make sure I'm not missing you. All right, so excavation is permanent. That means that when we excavate a site, we actually destroy the site. So we better know what we're doing. We better know that you read my little article, I hope, on what to do when you find an object. There are all kinds of questions we have to ask ourselves about picking up objects, about excavating areas, and so forth. All right, so we want to preserve for the future, because all of the techniques that we have today aren't necessarily all the techniques that archaeologists will always ever have, right? We always keep improving in science. So we want to preserve part of that site. We don't want to excavate everything. So we preserve portions of sites for the future. Archaeology and excavation is precise and painstaking. Archaeologists record everything that we do. So that way future researchers can scientifically recreate the circumstances that we excavated under, and validate whether our finds are true, or also maybe improve upon our conclusions. So that's important in science, isn't it? To be able to repeat the experiment. But because we destroy it, all we have is our written record. So, that makes archaeologists very careful about details. You will notice in your module that there's a page that I have asked you to look at that has my dig kit, and also some of my notebooks, some notes that I took while I was in a site called Lost Valley, which is a Cupeño site up in the mountains here in San Diego County. So you can just get an idea of the things that we look at and what we might record. All right, so what determines preservation? All right, so the how we look at preservation really is important, because we want to make sure that what we're doing conserves and preserves the past. So the exact procedures in any excavation depend on several factors. And those factors also include what is possible for us to find. So with the passage of time, certain kinds of materials disappear. These are usually organic materials. So basketry, leather, wood, anything that was once living, or from a living being, a living plant, is an organic material. Inorganic materials usually survive a lot longer in the archaeological record. So ceramics, pottery, stones, which is also called lithics. And we're going to have two labs in ceramics and lithics, and look at pottery and look at stone tools. And the other thing that survives is organic, but it's bone. So bone and teeth survive much longer than other parts of the body. Decomposition is what happens to organic things, right? And that's carried out by microorganisms. And microorganisms have to have warmth, they have to have oxygen and water to survive. So if those conditions aren't there, then things are going to be preserved a lot longer. So we do sometimes find baskets, and we do find leather and wood and other organic materials in places like deserts or in caves where things are very dry and there's no water. They're very dry. Maybe even they're buried and preserved with no oxygen getting to them. In bogs, you have that condition. We're going to talk about all these things. Okay, one thing I do want you to keep in mind about preservation and how we look at the past is how long stone tools last in the archaeological record. And if all we keep finding in certain places is our stone tools like arrow points and spear points, what assumption have we made about people in the past? I'm going to think about that for just a second. So people in the past who just had stone tools, and that's all we're finding of them, what did we decide that people in the past were doing? How about hunting? So we looked at people in the past as hunters. And from that, we looked at hunters as being men. And from that, we built on a real serious prejudice about what was important in hunting and gathering cultures. And turns out we were wrong, that, gathering and women's work was extremely important, but we don't see it because it's organic materials necessarily. But we'll be talking about that again all semester. But just kind of keep that man the hunter stereotype in your minds. All right, so this is an example of a really incredible artifact that survived time because it was in a cave. So this is a duck decoy from Lovelock Cave in Nevada. And these decoys were stacked up and stored down into that cave where it was really dry, it was really dusty, and no microorganisms could make them deteriorate. So that's one kind of preservation that you see in dry desert caves. This particular site was preserved because this is the archaeological site of Ozette, and it's in the state of Washington on the coast. And what happened was this village completely collapsed in a mudslide. So it was preserved by having been buried in mud. So oxygen wasn't able to get to it. It was really wet, but oxygen couldn't get in there. It was sealed off. And so that preserved all this wood and leather and things that we never see, and just a remarkable site. And you'll read more about it in your book, and we'll talk more about it. But the Makah people, who are the tribal people from Washington State for this site, they operate and control the area today. It's their heritage. And they actually also participated in the site's excavation. So a very interesting site. So that's another thing that was preserved by not having air get to it. And then this was very famous when it happened. This person, who we call Otzi today, the Iceman, it was in the Swiss Alps, and he essentially was freeze-dried. So you've got a lot of wetness, but it's very dry. And so this person was well preserved in that unfortunate grave. He was preserved in the glacier, and his tools were well preserved, including the wood. We could see the contents of his stomach, see what he'd eaten before he died, all kinds of incredible information. So as long as microorganisms can't interact in the way they do, organic materials can be preserved. All right, so here is what you'll see in some excavators' toolkits. Everybody's is different. And as I said, last time I went to the module and opened up in chapter 3, I opened up the page that shows my excavation kit, my dig kit. So have a look at that in chapter 3 if you haven't already seen it, and see what I carry with me. And these are some of the things that we normally see. The most important tool for archaeologists is their trowel. And I have a couple of them that you see in that picture. You also will see my field notebook, as I said, and see some of the entries that I made. All right, so this is important. And then let's start talking about what we do during excavation. All right, so first we might want to make a test of an area. And we talked about this in chapter 3. A test excavation or a test pit, or what I was calling, and what we called when I was working, STPs, shovel test pits. Test pits may not just be shovel test pits, but they may be bigger than that. So anyway, this is a test excavation. It's a small initial excavation to determine the potential in a particular place. So as I was describing it in chapter 3, I did lots of shovel test pits. I became really good at these long, narrow post holes. I could put up a fence like nobody's business, I guess, when I was done. But we dig them, very deep, and try to keep the sides very even, and that way we can measure where things are all the way down and see what the potential is in a particular site. So when we are actually any excavation, typically this test pit could have been a 1 meter square. Now, when we're doing a shovel test pit, it's a lot smaller than that. But any excavation unit is typically 1 meter square. And you're recording the X and the Y axes. So those are the horizontal coordinates. And then the Z axis is the vertical coordinate. So you've got something that you're measuring vertically, and you've got something else coming in this way. And I wish I had a third hand, I could say. And then so you've got 3 different things you're triangulating, right? 3 different measurements to place it in time and space. So vertical provenience is measured relative to the ground. So wherever the ground is, like if you're digging a pit, a test pit, or you're digging your unit and you've gone down 10 centimeters, that measurement starts at that 10 centimeters and goes up. Then you dig another 10 centimeters, and usually it bottoms out around 60 centimeters. So each one of those measurements of the vertical measurement is from the bottom of that particular level. Okay. All right, so here's a map of an archaeological grid system. And we can just look closely. We see that we see the 1 by 1 meters that are in each one of these. So you look at those white squares that are here, and this is a meter square. So here we see these larger units here that consist of 4 by 4 meters square. But typically we're looking at just one of those. So let's look at the number F, or I'm sorry, the letter F and the number 9. So here's the 9 row, and there's the F row. So we're talking about this one right here. Talking about this unit right here, F9. Let's look at J. Let's look at J3. All right, so here's J row, and there's, from J row, there's the number 3 right here. So this unit is unit J3. And then when we get these larger units that we're opening up into bigger units, then we start giving them Roman numerals, and that's what you see here. So this is just one way that archaeologists do it. This is a grid system. So as we open up these, say you find a feature in your unit and you want to open up and continue to see where that kitchen goes, or continue to see where that wall goes, or the hearth that you found, then you'll open up into those bigger units. All right. All right, and to excavate, we have to have a starting point that we're measuring from. So what we have is a datum point. This is the 0 point on the site from which everything else is measured from. We have datum points all across the United States because the USGS, the US Geological Service, went across this country and on a grid system plotted all of the land in this country. And in certain places, they would establish a datum point from where that was. So you can look at, if you remember from last chapter, you can look at in a GIS system, or you can look at on the, sorry, I'm trying to remember, on the Mercator system, or on the longitude and latitude lines on a map where your datum point is. Okay, so we establish a datum point on a site. It may have nothing to do with what the USGS did, but just something that we can find that measurement in time and space again. And that's our control point. So it controls both the vertical and the horizontal dimensions of the provenience. All right, so everything on the site is measured from the datum point. Measurements are both horizontal to the surface and to the area being excavated, and then they're vertical as the excavation proceeds down. we are looking at the horizontal spread of the artifacts and then the different levels as we go down. We're going down in time, presumably. Datums are often made permanent by putting a metal marker in the ground in some sites. So when we excavate, sometimes we see those natural geologic levels that are being peeled back as time goes down, going through time. So we see two different kinds of levels. We see natural levels and arbitrary levels. A natural level is what you see that the land has just made naturally. You can see the strata, the geologic strata. But those are really rare in some areas, like in particular California. So when we excavate in California, we excavate in something called arbitrary levels. And that's what I was just talking to you about. We decide on a measurement and we keep using that to determine our level. And usually, typically, it's a 10 centimeter in depth level. So each level is 10 centimeters as we go down. So that's arbitrary. That's not following what we see in the strata, which you might in another place. And we usually can go down until we hit bedrock. So that's how we measured. All right, so natural levels again. Site strata from which usually these levels look really homogeneous. We can separate them by looking at them. We can see texture or changes in color or the rock, or maybe there's organic material in, say, an old lake bed or something. These natural levels are preferred whenever possible. And then again, those arbitrary levels that I described. They're vertical subdivisions of any excavation square. So we only use them when we can't use the natural. Or when the natural strata is so deep that it's more than 10 centimeters. Then we might divide up that natural strata. If it's really big, a big, huge strata, then we might divide that up and use arbitrary measurements in that one. All right, so in the principles of archaeological excavation, we use a lot of geological terminology. So in some sites, as I said, the strata is not clear. We have a single stratum and then the strata that go down gradationally, and they're visible in some way. Or we'll see a break in the nature of the deposit. And this all becomes important as we look at how sites are formed at the very end of this. All right, so here's a good example to look at. All right, so this is how strata can affect what we're saying about the artifacts. So if you look at, this is being dug in arbitrary levels. So if we were digging in arbitrary levels, we have level A, B, C, and D. Each of those are, let's say, 10 centimeters. Each strata itself represents a unit in time. So if we excavated using these arbitrary levels, when we have strata, what's going to happen? I mean, you can see what's going to happen. Oops, except for I changed the slide. That didn't help. You can see what's going to happen. We're going to excavate. Okay, we're okay in the first level, in level A, but then we get to level B and we've got 3 different strata, which probably are 3 different time zones. It's 3 different periods of time, I should say. And the same thing with C. We see we're getting a little bit of this really early time period in here, and we've got C in these 2, and actually C also is in A. I'm sorry, B. Sorry. B is in A. C is also in B. And so, and so on, right? D, we've got, again, in these arbitrary strata, we've got the mixing of time. So that's why we have to be careful about that and understand when we're doing arbitrary levels that we may be mixing time periods. All right, so your authors, when they are looking at Gate Cliff, and their excavation there, let me just Okay, just want to make sure I'm on the same page here. All right, so in the Gate Cliff excavation, we talked about last time these flash floods that actually revealed some living floors that we didn't see before. And in this Gate Cliff cave, we see these distinct living floors. And then, in some of the other areas around the desert in Nevada, we saw some flash floods that did some other things. Okay, so flash floods helped separate what we call living floors. These living floors are the distinct areas in which people lived. The investigation shifted to concentrate on recording the spatial distribution of artifacts, those features and artifacts that were on that living floor, to help better understand that time period. And instead of keep digging down, let's plot out everything we've got on this huge living floor. So that's one way an excavation can proceed to go horizontally rather than down. All right, so discrete living floors in this excavation. So this figure shows how each artifact and feature on the living floor relates to the other one. And that's a really good example of context, right? We can see that, some places we've got these big mats here, a mat fragment. And what is, sorry, if I touch it the wrong way, the slide shifts. Okay, and what is it next to? Some areas are scraper planes, certain kind of work is going on here. Some areas are kitchens. So we can see that the precise location of these areas gives us not only the artifact's provenience, but its context to other artifacts. And how do we record this? Well, when we complete our excavation record, some of them look like this. This is very specific to this particular excavation. And if you'll notice here, from the last lecture, we talked about Smithsonian. I'm sorry. We talked about Smithsonian numbers. So this is the 48th state, not the 48th state to join the Union, but in alphabetical order, the state that's alphabetically number 48. And then we have the B and the H here for this site number, which is the county. And then in that county, whatever BH county is, this is the 3,178th site of that county. So this is Smithsonian. And remember, California, we do it differently. It looks differently than the Smithsonian system, and we just use our own system. All right, and go back to chapter 3 for that information. So this is completed along with photographs of the level that's being excavated, and sometimes the artifacts that are in situ are photographed. We have something called a Munsell chart, which you're going to find out a lot more about when we do our lab. A Munsell chart is used to describe the color of soil in geology, but it also gives us the color of things like pottery and other things. So it's a way that we can all agree on what color is brown or what color is light brown. And you use this chart and you match it with what your artifact or your ecofact or your soil is. And that gives that number. Okay, and then everybody can agree that they know what that color is. Video might also be used on the site. Today, a lot of that is done. As you can see, we collect soil samples, charcoal samples, and all charcoal samples for carbon-14 dating, which we're going to talk about in the next chapter, and plant or animal specimens. Not only do artifacts get a number, but features also get numbers, even though they typically can't be moved. We still need to refer to them and document them, locate them in time and space. So once you record and describe, for example, a post hole, when you're excavating, that post hole is gone as soon as you go down into the next level. Because typically what a post hole is just a color change in the soil. The wood is long gone, so it's disintegrated into this darker color. And you can see that a post was there, but all that remains of it today is just soil, different kind of soil. So we have to record that, measure it, and then as we dig down, it's going to disappear. All right, it's a source of pride, actually. I mean, we go very deep sometimes in archaeological sites, and you know, to record everything exactly is an important source of pride. All right, so let's look at the next slide here and talk a little bit more about this. Other things that can be used on the archaeological site. This is called a total station. This is a device that uses light to bounce off a prism in it that determines the artifact's provenience, and it's accurate to millimeters, so it's really, really precise. So recording the provenience of every item that they found in situ provides a really accurate record for this particular site, or for any site that uses this. In recording it, we record the top side of the artifact and the compass orientation of the long side of it. And then we can see its slope and its inclination. It's really very sophisticated. So we have some sophisticated methods like that we use, the total station. When I first learned to excavate, we used a line level and a tape measure to record the artifact's position in the unit. We took a measurement from the two sides of the unit, that horizontal X and Y horizontal, and then the Z measurement to triangulate where that was in time and space. When we excavate, we may have a rich site like the cave site that's described, and it can get very deep. Methods to hold up what are called the sidewalls. As you excavate down, you're excavating a square, and the walls are called the sidewalls. And then the bottom of the unit is called the floor. So we have to be really careful the deeper we get in things, because something has to hold those side walls up as we get deeper, or it collapses on us. That's not a good thing. So anyway, there are ways that people frame things out and are very careful about it. It's a really important source of pride, not only to have exact notes, but to also have a very straight sidewall and a perfectly level floor. And I was pretty good at that. I always felt pretty good at that. I'm messy in every other way on the site. I'm the dirtiest one, but I could keep really straight sidewalls and really straight floors. So that's fun. All right. The things you can do with a shovel. I don't do so much of that anymore, but I could. All right, so sifting the evidence. All right, when you're digging, what's coming out of that hole? Dirt, right? So potentially you don't see everything that's in that dirt. So you've got to figure out how to make sure you've retrieved everything for your very exact record that you're so proud of. All right, so digging's just the beginning of the excavation. It's impossible to map, recover, and see everything as you're digging. So we use something called a sifter, but more often called a screen. And these things are what we use to put that dirt in when our hand excavation misses it. The screen size that you have, because it's an actual screen, when you recover things, when you're sifting with the screen size determines what you're going to recover. So in California, we use very fine screens, 1/8 or 1/4 inch screens, because we're trying to find very tiny things like flake debitage. When you flake a projectile point or something, when you're making it, little teeny tiny pieces of stone come off, and it can tell you about the technique and everything. So we collect that. We also have very tiny shell beads here that are so small they would go through something bigger. We might not recover them. So we use a very small screen here. We also look for animal teeth to see if there's rodent activity. All right, so this is an example of those screens. And different ways that they're created. I always use a screen like this in the sites that I worked on. That's usually what was provided us. And this is really kind of fun because you stand either in the unit itself and your dig partner stands on the outside of the unit. Sometimes it has to be a little bit further away than what these two people are looking like, but you're throwing, you dig, you've got the soil on your shovel and you throw it across and hit that screen. You get really precise at it. And then the person screening shakes it, sees if there's anything, collects it and puts it in the appropriate bags. And then those bags get numbered and recorded. All right, so that's screening. That's one of the techniques in archaeology. Another kind of screening is called water screening and matrix sorting. So in water screening, you see the person here is putting dirt into this area, into the screen, and then rinsing it away. And sometimes the matrix is really sticky in certain areas and it sticks to artifacts and we can't see them, so we have to really break it up with water. Matrix sorting then is hand sorting in bulk soil. And again, it's looking very carefully for minute things that get stuck in soil. There's another important technique called flotation. And the lighter organic materials that we might miss in excavation can be floated to the top of water using the flotation method. Back to that stereotype of man the hunter, before we had these techniques, all of this organic material got missed. There was an archaeologist in the 60s and 70s, her name was Patty Jo Watson, and she did the first flotation. And she did this on Native American sites in which the burnt plant remains were able to be retrieved. And from that, she found information about all the domesticated native plants that the Indians were using in that area. Native plants from 4,000 years ago that had been domesticated, that we didn't even realize how important they were in this site until this technique. And then, some were 1,000 years before maize, but certainly, seeing the domestication of maize, we had to use things like this. Some cave sites gave us pollen and gave us little examples of maize and teosinte, which is what maize starts out as the teosinte grass and was domesticated into what we have today as corn. And that's a whole complex story, but very interesting. So anyway, we only knew about man the hunter. We did not know about women the gatherer. And those are also stereotypical. Some women hunted, some men gathered. I mean, more typically women were the gatherers because they were closer to the home base, the home encampment. They usually had children to tend, to nurse or whatever, and men would take on the riskier job of hunting, which often took them further away from home and put them in dangerous situations. But most societies gathering, what the women bring in or people who are gathering bring in is the bulk of what they're doing most of the time and the bulk of the important staple foods rather than meat. Meat is usually not a staple. It's something that everybody's happy about when it comes in, but it's very unpredictable. All right, so just thinking about how we retrieve objects from the archaeological record can affect what we say about what people were doing. And we stereotyped that it was all about men and hunting, and it wasn't. And also remember that men were the excavators initially. And so women's work and women's ideas and women's activities were not something that was important during certain time periods. And today it's very different. And there are a whole bunch of women archaeologists. So we have a very balanced, I would think, a very balanced viewpoint. And now we have people of many different cultures and ethnicities coming together in archaeology and people who are excavating their own people's sites. So you're getting a much more well-rounded view than we started out with. All right, that's decolonization, sometimes put in that way, right? All right, so one of the critical things that we have to do then is also catalog what we're doing. We have to create a permanent record of it. So as a museum curator and I worked most of my career in museums. I did a lot of cataloging. So there are many different methods of cataloging. The system is devised that the site number and the level and then the order in which the objects were found in that level are all part of its number. So when an object is found in the level, it's measured, recorded, and given a number. One might simply have the site number and then the second number is sequential to the order in which the artifact was found. So there's a couple different ways to do this. So you might have a number from 1 to 1,000, for example, in a site. The physical numbering and cataloging of each object takes numerous hours. It's very labor intensive. I spent hundreds of hours in labs doing that very kind of analysis in archaeology and in museum jobs. So archaeological site collections can need also to be stored. So once they're cataloged, their provenience, their measurements, all of their context is not lost. And archaeological site collections are often stored at universities or regional archaeological repositories. In San Diego, we have one, the San Diego Archaeological Center that we often simply refer to as the Arc Center. You can visit the Arc Center in Escondido. It's an ongoing problem, however, and here's the address for you, by the way, and the website. It's an ongoing problem to have storage facilities. It's very expensive to store archaeological remains of site excavation. There's so many of them. After the reports were published, the objects are required by law to be stored forever in a federally approved repository. But we're running out of room and we need to keep this evidence for the future research, but now we have more boxes of site collections than we have room to properly store them. So it's an ongoing problem. And this is just a flow chart of how, in excavation of where things go, who looks at it, and how the central database is formed. All right, the next thing I have is site formation. And sometimes I divide this into 2 different lectures, just depending on how quickly this part of the lecture goes. Since we're at 3:30 and I have office hours again after this class for another class, I think I am going to stop here and I will just record the rest of it and have you look at that separately as a different recording. Can you stay, Tanya, till 4 o'clock?
No, unfortunately I do have work, so I'll be logging off at 3:30 as well.
And that's what I'm thinking too. So, I could launch into this and you're my audience today. So thank you for being there. It always helps to have someone to talk to. So I really appreciate you being there.
No, thank you for the lecture.
Sure. So look for the rest, the site formation part of the lecture in your module. Okay.
Okay, I will.
Take care.
Okay. Thank you. Bye-bye.
Bye-bye.